So since I released the last video with my updated version of a Waveguide Cantenna antenna using a toilet brush holder, a few people have asked me if I could actually produce a video showing how I could make a circular polarized waveguide. Now, a lot of the things in this video are going to be similar to the last video, but because this time we're actually going to be using a 4-arm cloverleaf antenna as the main driven element, it's going to be mounted at the back here, so the actual base of the toilet brush holder is where we're going to actually connect our SMA connector so we can connect to this antenna. So there are a few little differences, but some things are actually the same as well. So first of all, I'm going to make the element itself, the cloverleaf, and because it's actually protected inside a can, I'm going to use a much thinner wire than what I would normally use to construct this antenna. And what I've got here is some earth wire with multi-cores inside, and this is actually the cores that are inside this are the perfect thickness to actually make this. The cores inside actually come out at 22 SWG. So when you've stripped it away, you've actually got quite a few lengths of copper wire here that you can use, and all you need to do is get 2 pairs of pliers and holding each end, just rub it on a corner, preferably wood, something like that, and it'll straighten out just nicely. So once you've got your lengths of wire actually straightened out, it's time to actually cut them to the length that we want, and we want to actually cut 4 of these to 126 millimeters in length, and that's one full wavelength at 2.4 gigahertz. Now you can use a ruler and individually trim each one down, but if you're planning on making a few antennas, have a look at actually using straws and marking one of those off to length, and that way you can actually use something like this to measure out wavelengths for your antenna and future antennas, and you can build yourself a little tool up that you can actually get out and use to measure off antennas in the future. So what I'm going to do, because I've got 2 kinked areas here where I've actually pulled them with the pliers to straighten them out, is just get rid of one end like that so it's nice and straight, and then just try and straighten it out a little bit with your fingers, and then pop it inside the tube, hold the tube flat to a flat area, and then get your side cutters and simply cut. And now inside there we've got one full wavelength, and it's a really fast way of doing it because you don't even have to take out the ones that you've already done. You can just leave them stacked up inside the tube there. Now something else that I like to do before we actually start putting the bends in this piece of copper wire is to put some heat shrink tubing roughly in the middle of that wire there, just so that when you put your bends in, the actual peak of that bend there doesn't make contact with the can itself. Now if you've done all your measurements correctly, the circumference of this cloverleaf is a lot smaller than the can, but I just like to do it just to make doubly sure it's not going to ground out, but in theory it shouldn't touch the side of the can at all. So once you've got your heat shrink tubing in place, we're going to put 2 more bends in here now, and we're going to put 1/4 wavelength bends into the cloverleaf. Now this is 1/4, that's 1/4, and this is half a wavelength here. So I'm going to use another little measuring tool here for 31 millimeters to measure off my copper wire, but you could also use a ruler as well. It really depends how many you're going to make. It's just a little bit more tedious with the ruler, and of course you can actually make mistakes as well. So if you're going to use a tube like I have, it's a lot more simpler. You can just use your measuring tube just like the previous one, but this time I'm going to come in with my needle nose pliers here with a nice flat surface there, so I can now lift that away, and then I know that this part of the copper wire here is exactly 31 millimeters in length. And what I do is just put a slight bend into that copper wire, not a right angle bend, but just a slight bend like that. And of course I do exactly the same with the other side. So to actually put that curve bend into the copper wire, what I've got here is a plastic tube. It is actually 32 millimeters in diameter, so you want to be looking for something around that 30 millimeter diameter mark, and I just bend my copper wire around my tube. So what I do is roughly line it up in the middle here and just use my thumbs to bend it around that plastic tube. Because we're using such thin wire, it's quite easy to do, but you want to try and get a nice smooth curve, even turning it over and giving it a quick roll out on the board there, and then finally bringing those arms in again to make sure you've got that nice curve and it's all nice and uniform. Now, to connect to this antenna, what I'm going to do this time is I'm using a short piece of this semi-rigid coax. It's 60mm long, and I've exposed the inner core here to a length of 6mm. Now, I've prepared this by tinning the sides around the top here, so it's about 2mm, maybe just over 2mm, where I've tinned up on the side there, and I've also tinned onto the inner core here just at the top. Now, this particular antenna is circular polarized, so you want to pay careful attention to what direction you want that polarization to run, whether it's left hand or right hand. Whichever one you choose, you've got to actually match that with a receiving antenna, especially if you're going to use this for FPV. Now, I'm actually going to construct a left hand turn one here. Now, if I was going to go for the right hand turn, I'd start soldering my bottom lead on this side of the coax here, but because this is going to be left hand turn, I'm going to solder onto this side instead. Now, because I've already got tin on the actual leg of the element here, and I've pre-tinned all around the bottom of the coax, it's just a small amount of solder on the end of your iron there. Just get the heat flowing, and you know, it's pretty strong there. It's not going to need any more solder than that. So the next element I'm placing underneath this leg here, and I'm going to solder it in at a right angle to the last one. So when all four are soldered in place, they're going to actually form a square around the outer braid of this coax itself. Now I'm getting ready to actually solder the final element in place, but hopefully you can see now what I mean by you want to form a square around that outer braid. There's lots of methods to actually build this, but this is the method that I use, and I just find it the most quickest and simplest way to actually get right. Before you actually move on and start soldering the top parts of these elements in place, you just want to double check that you've got the dielectric there, and none of this outer braid, you've got any spurs or anything making contact with that inner core. If you have, you can just get in there with a sharp blade and just trim any loose bits of solder away. So I'm now ready to solder the opposite legs of the element in place, and I'm going to be soldering them as close as I can to the top of this inner core here. So what I'm going to do, I'm going to solder them one at a time using the tension that's already in those that copper wire, just to hold it in place while I go in with the soldering iron. And just work your way around. Once you've got your first one soldered in place, you just want to be as quick as you can with the soldering iron, because you don't want to get all the heat travelling down there and desolder the last element that you've just done. So once you've got all the elements soldered in place, what you want to do is find yourself something like this reel, and just flatten the bottom elements to the flatness of this reel here, and then just give each of these elements a little turn while holding those bottom elements down, just to get more of that circular effect going on those elements. And now it's starting to look more like a actual propeller. Now what I actually like to do now is actually get some epoxy putty and just mould it in between each of the legs on the element there, and just around its centre, just to do a really good job of holding that in place, because although they're soldered in quite well, solder is quite a weak joint really for something like this, so a little bit of epoxy putty will do an extra job of holding those in place so they won't snap. You could also use hot glue or something like that, but I find epoxy putty does a much neater job. And hopefully you can see there as well, the one with the epoxy putty already on that I've previously made. This one is a right hand turn, and the one that we've just made on camera is a left hand turn, so you can see the difference there. So now I'm actually going to move on to the can itself, or what I should really call it is a waveguide for this antenna. And I'm going to be using a toilet brush holder again, just like I've used in previous videos. This particular one I've picked up from my local supermarket. Now normally for the previous videos I've shown you, we actually only want this part of the toilet brush holder, but this time we're going to actually need this little plastic container here, so make sure you put that to one side because we're going to need it later when it comes to actually mounting the element. Now what we're going to actually need to do is drill a hole in the base of the holder itself. Now I have used a compass in the past to try and find the centre of this circle here, but I've put some masking tape on there so I can actually draw directly onto this. But this part of the toilet brush holder, if you put that over the top of this, then it gives you a really good idea where the centre is for that circle, so it's much easier to just get in there with a pen or a pencil and put a dot in the middle of this smaller circle than it is in this bigger one. So use that lid there to actually help you. Now I've drilled the hole in the top of my waveguide here, and it is actually 4mm in diameter with a 4mm drill bit, and the reason I've chosen that size is because I want my semi-rigid coax to actually fit through there and have a little bit of play. But I am going to be putting some heat shrink tubing around this later, because the waveguide part of this antenna is completely passive. It's not actually connected to the antenna in any way, like a typical antenna is that I built in the last video. So you want to keep this completely isolated from the waveguide itself. So by the time I put a little bit of heat shrink tubing on there, it'll be a nice tight fit round there, and I can actually epoxy it in place, and we'll have a nice strong connection to the waveguide itself, but not grounding itself out. If you're actually going to solder onto this, you could actually have it a little bit wider and fill it in with solder, but because we're not doing that, you want to use a 4mm drill bit just so you get it as tight as possible around here by the time you put your heat shrink tubing on. So next I'm going to use this part of the toilet brush holder, which I don't normally use, but this time we're going to need this to actually space out our element 15mm away from the back reflector. So the measurements are totally different from the antenna in the last video. This element wants to be 15mm away from the back reflector. So if you cut this down to a 15mm depth and drill a hole through the centre there, there's a little nodule of plastic, so it's easy to find, and we can put our semi-rigid coax through that hole, mount the bottom of this element onto the top here. We can fasten it down with some epoxy, and then when we put all this inside of the waveguide itself, we know that it's exactly 15mm away from this back reflector, and it also helps support the actual element itself. So if you drop it, then hopefully this will give it some protection and you're not going to knock your actual element out of place. So I've got the element fixed in place here. I've got epoxy on each of these corners holding it down. I've also put some more epoxy putty around here as well, and on the underside to hold it in place there, so it's not going anywhere anytime soon. And with a stroke of luck as well, this plastic container here, when you cut it down, it's got this inner circle here, this ridge, and if you got all your measurements correct, the corners here that I've epoxied down should line up perfectly with that inner circle. So I've got the heat shrink tubing on the coaxial cable here, and I've also just put on some wire here held in place with some masking tape, and that's going up through the can and back through this hole. And to hold this in place, what I've got is some big blobs of epoxy here, and when I actually get this in place, I'll tip it up that way, and the epoxy will flow back down and actually attach to the can and attach to the plastic, and that'll do a good job of holding it in place. But because you've got to do this quite quickly, if you use some wire like this to feed this back up through into that hole rather than fiddling around with your hand inside, you can do it a lot quicker. So you pull it up through the can itself, and then you can flip it that way round, and the epoxy should drizzle back down and hold all that in place to the inside of the can. So I've just put heat shrink tubing around there just to tidy it up a little bit, and I've also gone ahead and put a tripod mount on here, just the exact same method that I used on my previous video, the can tenner video. So if you didn't see that, then I'll link it in down below. It's just some of those right angle brackets you can actually get off eBay pretty cheap, and this hole here has been tapped out so I can actually screw in a tripod mount. So now what I'm going to do, just like in the previous video, I'm going to use some cork matting to actually close this end of the waveguide off, and I'm just going to draw around it and cut it out with some scissors and epoxy that in place and just tidy it up with a sanding block. So I've got the test set up here, very similar to the testing of the can tenner in the previous video. The test router is about 65 meters away, going through 4 brick walls, and I'm actually getting very similar or a little bit worse signal strength than I did with the normal can tenner. So remember, this one's actually circular polarized, and this is actually a good example of how if you mismatch your antennas with a linear one and a circular polarized one, it can have a detrimental effect. Although to be fair, coming in about about 90% or 92%, it's performing quite admirably. So what I'm actually going to do now, I'm going to have to pause this, and I'm going to have to go over to my test router, and I'm going to swap out the dipole antenna that's on there for a circular polarized cloverleaf antenna. And of course both those antennas are probably about the same dB, so hopefully the test we're going to see next is how good the strength is when you actually have two matched circular polarized antennas working together. So I've swapped that rubber duck antenna for a circular polarized one, and now you can see almost immediately it's actually peaking out at 100%, so it's performing a lot better than the linear antenna with a dipole antenna did on the test router. So it's very directional, just like the normal antenna is, and once you get it dialed in there you can hit that 100%. So to be fair, the test router could do with moving back a little bit, because it's performing much better than the traditional antenna. So hopefully you enjoyed that video, and the test at the end there, it showed you what kind of performance you can actually get with a waveguide antenna being circular polarized, and of course having the matched circular polarized antenna on the test router as well. And just one thing I want to mention before the end of this video is it's got a much narrower beam width than a helical antenna. So if you are planning on using one of these for your FPV, this will give you a great deal of range, but I would actually run a helical antenna as well for when you're actually coming in much closer. So that's just something to bear in mind, because if you just move it a couple of degrees one way or the other, it can lose that signal in a big way. So again, I hope you enjoyed that video, and hopefully you'll join me on the next one.